Today we are going to
Please,
today
sir.
we are going to discuss about the role of computers in agriculture. So that is going to be one of the upcoming area. So right away I'm going to share my screen. So my screen is visible, I believe.
Yes, sir, visual, sir.
Yeah.
Good, sir.
So computers in agriculture. So before going to the field of agriculture, so nowadays computers are part and
So sorry,
parcel.
sir, your screen is not visible.
Screen is visible, sir. No problem. Okay.
Okay.
Okay. So nowadays computers are parts and parcel of our day-to-day life. In most of the fields, wherever we go, so we can see computers. Not only there, and even in our pockets also. Computers in the sense earlier, we have computers in the sense we need to have CPU, we need to have monitor, and all other setup. So nowadays, whatever there in your pocket, so that is also going to be a minimal miniature of the computer. That is nothing but your mobile phone and your tab, so many other things. So as and when there is going to be an advancement in computers and also different technologies in computers, so that will be, that is going to help, and that is going to help in solving the problems in various domains and various fields. So in particular, so today's the topic is computers in agriculture. So before going to see how computers help and what is the role of computers in agriculture, so first we'll start with the introduction and today's lecture. So I made the content as first start with agriculture introduction. So after that, the current issues. So in the traditional approach, and then we'll go for most foremost and very important domain, that is precision agriculture. And after that, we'll discuss about the different stages of precision agriculture. And among precision agriculture, so one thing is going to be crop management. So there we are going to discuss the general steps in crop management. And next is what is the role of computers in agriculture and the future research avenues in computers in agriculture using computers. So we all know that agriculture in the sense it is backbone of every nation because it is going to be the primary source for survival of humankind, and it is also source of income and employment. So the thing is, India, especially Indian scenario, agriculture is going to be one of the foremost and wide occupation. So in India, and also it is providing food for the livelihood of humankind. So from so many years, so there are going to be various technologies. So that is going to help in case of agriculture for various purposes. So we'll see one by one. So first thing is there are current issues. First, we need to see what are the issues. So that is going to be addressed immediately. So in order to, go for good things in agriculture. So one thing is rapid increase in population. So the thing is earlier, so whatever the agriculture production that we have, so that is going to be sufficient. But nowadays we can see that rapid increase in population, and also there is going to be quick urbanization. So that means so we can see that in any of the city you consider, for example, in Mysore also you can see that. So if you see outskirts of Mysore, so many lands have been converted into the the sites, and also some layouts will be there. And so that means what? The amount of agriculture land is diminishing day by day. So with this as a very prime issue. So whatever the area that we have, so in that area, are we able to grow sufficient food that will supply for the increased population of our country? And so if you see that in India, so normally 80% of the agriculture, so they are maintaining a manual approach. And manual approach in the sense, so it is going to be ad hoc manner, and there is no strategies that has been there in the manual agriculture. and the process is going to be cumbersome. And still till date, so people are managing the same thing. And this non-strategic approach, which leads to excessive and needless use of agrochemicals. So that means we might have seen that if you go to any of the field and other things. So farmers are simply there, supplying the agrochemicals and manures, whether it is needed or not, without doing proper analysis. But from a decade onwards, so we can see that there is an improvement. So the concerned departments like an agriculture department or horticulture department. So people are going for now, they are doing some soil-based analysis, and based on that, they are going to see what type of nutrients that are present in the soil, and based on that, they are going to supply accordingly whichever is needed. So that is going to be one of the prime thing that is happening from last 1 or 2 decades in India. And along with that, availability of laborers is going to be one of the biggest issue nowadays. So whenever we talk to any of the person who is having a farm or who is having a land, so most of the time they are complaining that, laborers are not available. So that is due to quick urbanization, and people are getting lot of opportunities in other fields. So they are attracting towards the urban cities. So they are leaving their occupation, and people are not getting sufficient laborers, especially skilled laborers. So in case of plantation crops and other things, so getting skilled labor is going to be one of the biggest challenge. So because in my research, I considered as precision agriculture is the domain. I considered plantation crops as a case study. And whenever I just visited a few farms, so there I came to know that most of the time, so the landlord or the farmers, they are complaining that getting the skilled labor is going to be one of the biggest challenge. And not only the labor, the decision making is going to be one of the very important stage, not only in agriculture, in any of the field. If you are going to make certain decision in the sense, so based on what parameters, what facts that we are going to make the decision, and whatever the decision that we are going to make, so whether it is going to be beneficial or useful for the further actions. So in case of agriculture, so most of the things now we can see that, especially in Indian scenario, so it is going to be manual. And also this decision making, it will vary from person to person. So one person, he may share in his view. So accordingly, he may take a decision, but it is not common across all the people or all the farmers. And another thing is no analysis or study on crop yield. See, most of the time we can see that, and in newspaper also we can see that due to one or the other factor. So this year yield is very minimum. So we have expected per acre, we have expected this much yield, but we are not able to get that much. And actually the analysis is not happening in that case. Analysis in the sense, so only the technical people or only the agriculture department wise, they may do certain analysis, but at the farmer level, analysis is not happening. So because there are so many reasons for this, especially the minimal yield, that is because of there is no variability of crop in the field. That is going to be one of the area. So people are growing similar crop. If they are going to grow paddy or ragi or some other thing, so they keep on doing the same thing in the same field for many years, even 10, 15 years, they will be doing the same thing. There is no variation of crop in the same field. That is also going to be one of the issue. So in order to overcome these issues, so there is going to be a concept. So that will be from last 2 decades, we can see this concept in Western countries, and they are using technology and engineering. So we all know that from last 10, 20 years, even in India, we can see the rapid growth, especially in case of information technology, communication, and signal processing, so many other things, especially the artificial intelligence. That is going to become boom in each and every. From last 10 years or 20 years, we can see that there is a boom in artificial intelligence application. So by making use of all these things, so they come up with a concept called as precision agriculture. So precision in the sense, whatever is needed, how much is needed, only that much that we are going to, in precise form, we are going to use those things. So it is nothing but it is both technology as well as engineering driven concepts. So especially for management of crop. So crop management in the sense, there will be different stages of crop management, start from the nursery level till we are going for harvesting, and also not only harvesting, still we are going to store those, the crop. So precision agriculture main aim is to meet economical, environmental, market, and public demands. So as I mentioned earlier, So since growing population and also lot of urbanization is happening, and the agriculture land is going to be, it is diminishing day by day. So this is going to be a biggest challenge for the increased population. So with the minimal, whatever the area of land that we have, so in that, whether we are able to supply that much, whatever the expected level quantity of food, so to the population, that is going to be the biggest challenge. So nowadays, and in future, in another 10-20 years, so definitely we are going to see there is going to be scarcity in case of food, because of urbanization is happening like anything, and population is also increasing. So in another 10-20 years, if you are not going to adapt certain technologies into agriculture, it will be very difficult for the humankind for their survival. And another thing is improvement of crop quality with environmental concern for better profitability. So whenever I'm discussing about improvement of crop quality, so nowadays we can see that something called organic foods. So many years we started, using a lot of chemicals into the field, whether it is needed or not. Unnecessarily, we are, farmers are providing chemicals into the field, and they are injecting certain chemicals to the crop, and they are getting a good yield. But what is the quality of the crop, quality of that crop? So that is going to be another area of concern. And with all these things, so we need to collect a lot of data. So the computer comes into picture when we are going for handling and processing data. So data in the sense, it is not in terms of, simply KBs or in megabytes. So we have to handle gigabytes, zettabytes of data. So because field in the sense, I need to get data in different areas based on the technology, what that I am going to adapt to my agriculture, I need to collect those data. So in order to process the data, and why we need to process the data? Because we have to make some decision. So there it is going to be the biggest challenge. So how to handle this data? So manually handling is going to become very, very difficult, and it's not possible. So because if you consider 1 acre of land in the sense, suppose I'm going for a new technology nowadays, I think you are aware of that. That is, IoT, Internet of Things, agriculture IoT. We are going to call it as agriculture IoT. So that means what? So I have to adopt, suppose if you consider 1 acre of land, so I have to collect different types of data by making use of certain sensors. So in order to sense the water level in the soil, and also the temperature and the humidity, so many factors I need to collect those data. So when I'm collecting that data, it is going to be very huge. Storing the data and processing that data, it's going to become very cumbersome. And in order to do that, so manually, it is not possible for human being. So what we have to do, we have to go for computers, that to be high performance computers that are needed. And so all these concern that make us to forced to adapt machine vision and machine learning techniques, especially for decision making. So the decision making in the sense, so I can just, go one by one. Decision making in the sense, so the first stage in agriculture is, so based on my location, which crop is suitable for my location. So that is going to be the first and foremost decision one has to make. So there what we have to do, we have to go for the availability of water resources, and also the soil nutrients, whether it is a black soil or red soil or different things, and also soil nutrients, that plays a vital role. Before I'm going to select for a particular crop, so I need to analyze the overall land, and these parameters plays a vital role. So based on the water resource, if water resource is minimal, then I have to go for a different type of crop. And nutrients like salts will be there, just like sodium will be there, potassium will be there, so many other things, salts will be there as a nutrient. So based on that also we need to choose, that is, we are going to call it as the soil to crop mapping. That is going to be the first stage in precision agriculture. So in the next slide, I'm going to show different stages of precision agriculture. So first thing is assessment of crop variation based on region and season. So whatever just now I discussed, that is nothing but the location based. So I have to assess whether this crop is suitable in this part. So that is going to be the first analysis one has to make. And also based on the season, suppose if it is rainy season, in the sense we have to think of, so any crops which needs much water. And if it is going to be summer, in the sense we need to think of other thing. And also variation in crop management. So in the first point I mentioned that, so from last 10 years to 5 years, people are doing, the farmers are growing the same thing, paddy, in the sense only paddy. And that is also going to be one of the impact on its yield. So it is not giving expected level of yield. So that is need to be addressed. So before choosing the crop, what would be the variation that I can do? That to be specific to the region. And after that, the evaluation process. So in that evaluation, whether I need to evaluate the resources like water resources and also the nutrients in the soil. And these are going to be the primary steps. So one has to make before they are going for growing any crop. And in this stage, variation in crop management, here we can see that what are the variations, different steps of crop management variation starts with soil fertility management. So as I mentioned that we have to analyze the soil, quality of the soil, what are the nutrients that are there in the soil. And after next is nothing but pest management. So this is going to be another thing. So when soil fertility is matched, okay, we are going to select certain crop has to be grown in that region. And whenever we start growing that at the nursery level itself, there is going to be a problem with pests. It's going to attack on the crop, and that leads to once again a poor yield. So what to do that? How to manage those pests? And next stage is nothing but the crop management itself. That means when the life cycle of a crop. So when I'm going to start growing the crop from the nursery level, and what are the different things that are there. So for example, if I want to manage the crop in the sense at nursery level, so I have to have a technology to detect the weeds. That means it should classify and categorize between the actual plant and the weed plant. So that is going to be another thing that we need to do under crop management. And after that, water management. So based on the water resources, nowadays we can see from last 1 or 2 decades, we can see drip irrigation is in place. So all these things are manually that they are doing, but that is giving good result instead of wasting much water. So whatever is needed, so that we'll go for that. And after that, soil management. Soil management in the sense, first we need to see whether all the soil is acidified. So what we need to do, what treatment that we need to give for the soil and other thing. This comes under crop management variations. So based on that, so we can go for a particular crop. So the next stage we'll see the general steps in crop management. First thing is soil fertility evaluation and soil to crop mapping. So this plays a vital role. So we can expect a good yield provided if the crop is best suited or the soil is best suited for particular crop. So this analysis and mapping is done in the initial stage. So that is going to become 50% of the problem will be solved. And after that, disease crop mapping and control at nursery and plant level. So diseases will be there. So how to maintain that? So disease-free plants always going to give good yield. See, whenever we are considering this is not like just like 1 or 2 plants. It's nothing but whole area, acres of area that has to be analyzed and that has to be managed properly. And next stage is going to be weed mapping and control. So based on certain crop, certain types of yields will be specific when we are growing those crops. So that has to be seen first. So which is going to be the crop and which is going to be the weed. Otherwise, whatever the nutrients that we are supplying to the field, so that will be consumed by the weed rather than the crop. And after that, timely harvesting, that plays a vital role. That means when I have to harvest. So in this case, actually, just like, cereals like the paddy, ragi, and other thing, jowar and other thing, so that they are having a different levels of harvesting. And at the same time, some plantation crops like areca nut, and then we have coconut and some other thing. So they have different style of the harvesting. So there also, if you are going to harvest a crop in time, at a right time, so that means which yields good profitability, and also we can provide so good quality crops to people. For example, in case of mango, we all see that. See, properly ripened mango or properly timely ripened mango, if that is harvested in time, so the taste and other thing will be different. Same thing if they are going to do in the immature stage, and they will put some chemicals and they will change the color. So that taste is entirely different. And all these things. Next is classification into different grades. Grading of crops, that plays a vital role. Any crop, if you take for this matter, whether it is fruit in the sense, grading of fruit. Suppose if you go for, the cereals also, there is going to be different grades will be there, and fruits in the sense, different grades will be there. So like that, we can do different grades, and not only the grades, and also within that, different classes. For example, if you are going to take banana, so banana in the sense, there will be different classes of banana, just like, Elaki banana, then we have, Pacha Bale. There are different things will be there, even that classification. And next, disease detection in growth and also post-harvest condition. Post-harvest condition in the sense, after harvesting, we are going to store crop in certain area or godown or some other thing. There also there is going to be chance of, some mite attack and other thing. So that is also, that can be captured. Now, role of computers in agriculture. So previously, whatever the crop management stages that we discussed, so we can make use of computers as well as the artificial intelligence and machine learning solutions in order to address those issues. So with the invent of computers and advancement in computer technology, which did a paradigm shift in different aspects of agriculture. So the thing is data acquisition and analysis. Data acquisition in the sense capturing the data, how to capture the data. So technology is helping us. So we are capturing the data using certain sensors, and whatever the captured data that will be fed into computer, then we are going to do analysis out of it. And second part is nothing but precision agriculture. So this is very much appreciated in the globe, and so many countries are there, very pioneers in agriculture technology. And India is just, they started from last 1 decade, and it is also improving. And along with precision agriculture, field management. So as I mentioned, so plant taking care of crop management in the sense, it is not restricted only to the single plant. So it is for the whole field, how I am managing whole field. So your agriculture IoT comes into picture. So based on that, different areas in the field, so I have to set up certain sensors, and from those sensors, I'm collecting the data, just like water resource. Suppose if it is a summer in the sense, water resource will be less in the soil, so that I have to supply more water. And this process will be automated in case of agriculture IoT. So whenever the sensor, it is going to sense particular area in the field, so the soil is drying very quickly. So at that time, so that will be, that data will be sent to the control system, and control system is going to supply certain water into that place itself. Not only that, even humidity, so that is also going to capture. And next is crop monitoring. So monitoring the crop in the sense, different stages has to be monitored. So once we start growing, once you put certain crops into field, from that time itself, we start managing the crop, monitoring the crop. For any pests will be there, any weeds are there in the field, and how to remove that, and classification of weeds compared to the crop. So based on that, technologies will be used, so in order to differentiate the weed with plant. So that comes under crop monitoring, and also the disease detection. So disease detection at the initial level, at the nursery level, is going to be one of the important tasks, because if it is not treated in time, so there might be a problem of spreading the disease through the whole field. So that leads to, once again, that leads to huge loss. And another is weather forecasting. So based on the different criteria, so we can predict that certain areas, parameters will be there. Based on those parameters, we can predict, so what would be the weather for next day, next week, next 1 month. So based on that, even that is also part of our computing technologies that can be used for forecasting the weather by considering so many parameters. And another important thing, improvement in precision agriculture, is nothing but automated equipments. Automated in the sense, it is going to be self-driven equipments. So suppose I want to harvest something. So in US, actually, I have seen in the literature, in US, in 90s itself, they started doing some tomato harvesters. So tomato in the sense, they are growing tomatoes in hectares. So there actually they want to, they were fixing some equipments into the device or the vehicle, just like whatever the tractors that we are using. Similar to that, they have designed the vehicle and they have fixed that system into that vehicle, and that is keep on moving in the farm while going that itself. So a camera will be fixed, and that is going to differentiate ripen fruit with non-ripen, and it is going to pluck those fruits from the plant, and it is going to store that into different area. And not only for harvesting, even manure distribution. So manure, how to treat some salts that we need to do, especially potassium will be there, sulfur will be there, something that we need to spray. How to spray that? For that also, there are some automated equipments will be there. And these equipments have been controlled to computing systems. So based on that, we can have a tab or simply our mobile phone. By making use of that, we can control these equipments. So that is going to be another computing technology that will be very useful in precision agriculture. So not only that, even watering. Watering in the sense based on that. See, already I mentioned that if the field is dry, so I need to supply water. So previously what's happening? So farmer has to go to the field and he has to run his motor and other thing, and he has to supply the water manually. But now it is converted into automated. So based on the temperature or based on the dryness in the soil, so that will be sensed by the sensor, and same information will be sent into the control room. From there itself, automatically the motor will start and water starts sprinkling into that area. And spraying pesticides and insecticides. So earlier we are doing this in a manual way. Simply we are going each and every row, we are doing that, whether we have disease or not, but we are supplying pesticides and insecticides. And actually this practice is still it is in practice. If you go to the rural areas nowadays, we can see that whether it is pesticide is there or not, simply they were doing that as a precautionary measure. But this leads to, once again, this minimizes the quality of the fruit, quality of the crop. So in order to do all such things, so what we need to do is, there is going to be, we have to come up with different machine learning models. So that will be used for exclusively for crop management. So not only that, market analysis. Now I think we can, we have read so many times. So farmers are growing excess. They will come to the market while for selling their crop. At that time, prices are rock bottom. So many times we have seen in papers, we read in papers and we seen in certain news. So people are just throwing their crops into the footpath or into some other place, dumping into that, and simply they are going. So what is the cause for this? The first and foremost thing is, suppose we'll see that if tomato is having 150 rupees per kilo, so everyone starts growing tomato. So we are not going to do any analysis. What is the demand and supply? How much demand is there? Without knowing that, without analyzing that, simply everyone is growing the same crop. So that leads to excess production of the crop. And at the time it enters into the market, so the prices will be rock bottom. At the same time, so farmers will be feeling that, so whatever the thing that we have spent, we are not getting even that much. So that is very, very disaster. So because of market analysis, how market will be. And at the same time, we need to analyze so different areas in and around. For example, we'll take an example of tomato itself. So what is going to be the demand of this tomato this month? So based on that, they have to plan accordingly, and they have to do certain analysis based on the market, and then they start planting own tomato only that much. So at that time, even cost will become stagnant. So there is no fall down of the cost, and it will remain as it is, and it makes farmer is profitable. And another is supply chain. So that means once I start growing my crop, so whom to supply? That is going to be one of the questions. So many times this onion and tomato, so we may hearing from farmers, they are telling that, so we are selling it for 10 rupees per kilo, but in market it is 50 rupees per kilo. There is no proper supply chain. Even that needs to be addressed, and computing technologies plays a vital role in this case. Next is market accessibility. So I have grown the crop, I got a good yield, but where to supply? This is going to be the question. Whether I need to supply in Mysore market, if I go for some other market, so that I can get much profit. Even that is also, see, these things will be mapped one to one, so that our computing technologies are going to map all these things, and it will help farmer to make proper decision so that he cannot incur loss. Now, computing trends, different computing trends. So one thing already I mentioned that it is IoT. So IoT in the sense Internet of Things. So agriculture Internet of Things in the sense communication among on-field devices. That means I need to implant certain devices in different areas of my field, so that there should be an intercommunication between those devices, and based on certain area, so those data will be sent into the control room. So through control, my computing techniques or technology, it is going to handle those things. So this is going to be one of the very popular in 2024 onwards. Still, we can see that lot of growth in case of Internet of Things. And next is robotics, that is autonomous devices. So we are making use of robotics for the autonomous devices. Actually, this is robotics comes into picture by the combination of different technologies, just like mechatronics, combination of mechanical and electronics, along with computer science, along with computation technology. So this plays a vital role in case of robotics. And another thing is artificial intelligence and machine learning, that is especially for decision-making process. I want to make a decision. How I am going to make a decision? I have to build certain intelligence into the machine itself, so that it can think and it can decide based on whatever the data that it is getting. Next is agri drones. So this is going to be another wide area. So they are manufacturing drones. Nowadays, we have seen that in India also it started. Now they are going to, spray either manure or pesticides or insecticides or any other thing by making use of drones. So this plays a vital role for the uniform distribution of medicine over the field. It's not only area specific. So because if it is a huge field, so spraying each and every row, that is going to become very cumbersome. So as I mentioned earlier, one thing is the lack of availability of skilled laborers. That is also going to be one of the big issue. So by making use of these drones, so the uniform distribution of medicine over the field, that can be controlled. And next one is precision agriculture. That is going to be one of the important thing. So there we are using huge computation technology. So that is for crop management, start from the nursery level and in intermediate level, at the time of harvesting, after harvesting, grading and classifying different things, even at the level of storage. So it is going to cover one cycle of crop management. Next is agriculture biotechnology. So even biotechnology is also part of the computing technology. There they are going to do the analyze crop analysis and what is the finding. So finding in the sense, what is the shortcut? What happened to that? So we can include certain biotechnology strategies also into the field, so that we can have very good yield. And next one is big data and analytics. In Internet of Things, robotics and other things. So these devices collecting huge data. So how to manage these huge data? So earlier, these data are maintained using high performance computing, high performance storage devices. But now with the advancement in storage technology and cloud computing, so that is in picture. So we can directly connect the devices and put the devices into whatever the data that can be directly put into the cloud. And if we put into the cloud, we can collect the data from anywhere, anytime throughout the cloud. So that is going to be the another computing technology, big data and analytics. So organization of voluminous data and analyzing those data. So whether it is going to be, there is going to be scarcity of water in the field. So what we need to do? There is no sufficient water in my bore well or some other thing. So what I need to do? So I can take a decision well ahead, and that stops suffering the crops without having water or some other nutrient, some other thing. So these are the computing trends in agriculture. Now you can see that I have put certain pictures. So in the left top corner, we are having one device, and that is nothing but the weed detection device. So the device has put a camera, and with that camera, it's these are the autonomous devices. So it can be controlled with your tab or some other remote. So you can do that. It keep on moving in the field, and it is going to see that which is the weed and which is going to be the plant. So it is going to differentiating that, and it is just pouring some medicine on only on the weeds, not on the crop. So that level of precision will be there. And in the right type corner, we can see that there is going to be an automated harvester. So that is nothing but it is using the technology of robotics, and there it is going to see it is nothing but a tomato harvester. Normally it's a tomato harvester, and it is going to see that, so which is the tomato fruit, and based on that fruit, it is going to see that this fruit is ripened, properly ripened. A camera will be fixed into that, and by doing that, so based on some color-based analysis, it is going to pluck those tomatoes. So that is nothing but timely harvesting. And next one, in the right bottom corner, you can see some picture. So which is 58%. That is nothing but water resources in that area, and 73% is nothing but the temperature in that circle. So this is nothing but what agriculture IoT. So we have put some sensors, so which is going to detect the water level, at the same time which is going to detect the temperature level and sense those things and sense these parameters and send that into control room. So based on these data, a proper data processing things will be done and a decision will be made. So where to supply water, which is the area which is suffering. And in the left bottom corner, you can see that using the drones, agri drones, for spraying chemicals over the field. So this is the role of different computing technologies or computers. So whatever the sensing data, it will be fed into the computer. In that computer, we are having some machine learning and artificial intelligence algorithms. So that will be, processing the data, and finally it will come up with a good strategy to manage the crop in the field. Next, role of AI and machine learning in agriculture. So already we mentioned only that thing, crop variability based on soil. So we can see in literature, so a lot of algorithms have been built, lot of computation technologies that is in use. People are doing that for crop variability based on the soil, and for weed detection also, lot of research is happening, and there it is differentiating between the actual crop and the weed and spraying the chemical only on the weed. And next, monitoring the plant health. So that is one of the prime thing, that is detection of diseases at the nursery level, intermediate level, at the time of harvesting also, and then even post-harvesting situation. Proper crop selection for harvesting. So in this case, we are selecting appropriate crop to harvest. Not every crop will be. See, properly ripen or slightly ripen things can be harvested. And disease detection, same thing, initial, intermediate, and final stages of growth. Next is crop classification, different classes of same crop. As I mentioned that if you go for mango, we are having Rasapuri is there, Badami is there, so Malagoba is there. There will be different classes of that. Even that can be classified using computing techniques. Next is crop grading, based on different features like shape, size, texture, color. So these are going to be the features. Based on these features, so we can grade a crop which is having A grade crop or good quality. So if you go to market, we can see that even apple also, people will say that this is 200 rupees per kilo, this is 160 rupees per kilo, and another is 120 per kilo. It is based on proper grading. Even that grading can be made, algorithm can be built in such a way, accurate grading can be done in case of different crops. So now next part, just I want to discuss, I'm going to discuss about the my research parts. So my research, as I told that it's going to be a precision agriculture, and in that I have considered the plantation crops. So I have taken areca nut, coconut, as well as oil palm. So these three things that I have considered, and let's see what are the different things that we have done. In brief, I'm going to tell you. Selection of proper crop for harvesting. So in this case, you can see that there are, in the top picture, you can see that areca crop is there, and even coconut is there, and oil palm is there. In case of areca and oil palm crop, So the harvesting process itself is very difficult, especially in case of areca. We need a skilled labor who can climb the tree like anything. And we know that if you see in the areca plantation, the distance between one tree to another tree is going to be only 1 or 1.5 feet maximum. So each and every time he cannot come down and he cannot do. Instead, what he will be doing is, the skilled labor is who is going to harvest the areca is simply going from one tree to another tree and at the aerial level, and he is doing the same. And at the same stage, lot of accidents have been reported, falling from the tree and other things. And in order to do that, so we have discussed with some agriculture universities also. So there actually the thing is manually they are doing that, a tree climber. So one thing, especially in Shimoga district, we have seen that tree climber. So it's simply it is going to climb the tree from there itself. So you have to do, but it is not totally automated. It is a manual. Simply it will climb, and whatever you show, it will cut down that bunch of things. And in case of our research, we used 3 different crops and segmented. We use the process called as segmentation. Segmentation in the sense we are going to, from that image, whatever the image that it is going to acquire. So we have to consider only the particular image by neglecting the background. That we are going to call it as segmentation. And in this case, we used different color-based models like CAE, HSV, and YCBCR. And these are specific models that is available in computer vision, image processing, and video processing. So we have used the same thing in order to segment the thing. Actually, we try to do complete harvesting system, but with only machine learning and AI knowledge, we are able to build only the vision system. So because we cannot adapt that into the autonomous vehicle. So once again, it needs the intervention of the electronics as well as mechanical areas. So just we developed a vision system. Any image will be given. So it is going to consider which part of the crop, and it neglects the background, and it is going to consider only the foreground in order to capture the respective crop. So while capturing also, certain decision making is going to happen. So what to capture? So in case of second picture, you can see that. So capturing the coconut in the sense they'll be doing for different purposes. One is for they want to use it as a tender coconut. So at that time, say in the initial level do. Suppose if they go for the coconut, the edible coconut at that time, so they are going to see that the texture of the coconut, how it would be. So here it is totally green in the sense it can be used as tender coconut. So even in our work, we use the same some other machine learning techniques in order to classify whether it is a tender coconut or edible coconut or copra. So this is nothing but crop classification model. So in this crop classification model, so in our work itself, this is one of our work. So there actually we used classification model in order to classify coconut into 3 things. One is going to be tender coconut, another is going to be edible coconut, and another is copra. So based on the texture and color, both the features that we have collected, and finally we use certain classifier, a number of classifiers that we used. Finally, upon matching that, we are able to label the crops like tender and actual edible coconut as well as copra. And we are able to achieve around 90 to 93% of accuracy. Out of 100 images, we are able to, our model is able to classify out of 92 to 93 images properly. And in the second image, if you see that in the right side, so this is nothing but classification of the oil palm bunches. So in case of oil palm, one is, it is under ripen, another is ripen, another is going to be over ripen. So over ripened in the sense, it is not going to yield much profit. So at the same time, proper classification at the time of harvest, we have to consider only the proper ripened crops so that farmer can have very good profit. He can gain very good profit, especially in case of oil palm. And this oil palm work, see most of the literature when I gone through, so most of the work is done in Malaysia. Malaysia, they are doing good work on this oil palm thing compared to our India. Next is disease detection in stored areca nuts. So as I mentioned earlier, so disease detection will be, it can be detected in various stages. From the nursery stage, that means disease on the leaf. leaf disease detection that can be done at the nursery level or during its growing level, intermediate level. And after that, there is going to be at the time of harvest also, we can see that there is going to be, but certain things will be infected before harvesting stage and post harvest, especially in case of areca nut. They will store this areca, whatever the harvested areca, they will be stored and they will be waiting for the market value. So many times we can see that, a year or two, they will just dump and they will store all the areca nuts, they won't sell. And when the market is high, then they start selling. Farmers are selling that. At the time of storage also, there is going to be infection will be there. There is certain mites that is going to attack on the stored areca nut. And finally, so we have done that using some segmentation. And after that, there is conversion, then image complementation and detection of infected spot. So that is also we are able to do using our computing technology, especially the AI models and machine learning models. So next is decision detection models for coconut. So in case of coconut, we have seen one interesting thing. So based on the patches on the coconut, so this is a severe affected with mite once again. So Kannadadalli ನುಸಿ ಅಂತ ಹೇಳ್ತೀವಿ. So in that case, so it is going to affect the coconut quality. If they are using for the coconut oil extraction, or even if it is used as a tender coconut, taste of that juice will be entirely different with infected and healthy. So we build a model. So in order to detect the disease based on percentage of affected area. So when they are manufacturing coconut oil, so they are going to see that they are going to store good coconut. So for a very good quality coconut oil. So at that time, they will be doing certain percentage of infected. So in this diagram, you can see at the end, so healthy in the sense, there is no white patches, but white patches are there in the infected. So based on the pixel arithmetic, we are able to, compute how much of the total area of our coconut that has been affected. And here, actually, we have a limitation. So whatever the images that I have taken till now, so we restricted our work only to 2-dimensional images, not 3D. Suppose if we see that only infected area, one side it is able to visible, and the other side it is not visible. So in order to overcome this, we have to work on 3D model. So once again, it is going to be very challenging, and also it is going to be one of the part in precision agriculture. Next, at the nursery level, so we have considered the case of palm leaf disease detection. So we can see that some spots on the leaf. So one is the healthy leaf and another is going to be infected leaf. So if you are going to use that video, so automatically it is going to mark certain part of the tree, it is going to be infected. Those leaves are infected. So in this case, we used segmentation using some technique called color threshold. And after that, we retained the infected part and converted background pixel as black. That means whatever the area that has been infected, only that will be remain as it is. If other thing, we converted that into different, so that we should know that which leaf is infected. And this helps us in separating healthy image with the infected. Healthy in the sense, no spots will be there, that will be healthy, and infected in the sense, certain spots will be detected on the leaf. So this is about the palm leaf disease detection. Next, so now we are discussing about in the globe, everyone is talking about precision agriculture and use of some technology in agriculture. So we'll see certain leading countries. USA is going to be the first country which is using most of the technologies for their agriculture, and Netherlands, it stands second. So there they are having, that is also based on the agriculture products, and they are also adopted well technologies. So in order to do their agriculture. And Israel, we already know that Israel, in the sense technologically they are very sound. They are coming up with so many new techniques. So being a desert, they are unable to grow proper thing, but they are doing wonderful in case of technology. They are coming with different technology, and they have adopted the combination of vertical farming in the sense with the small area, one above the other, just like a rack. So we can grow certain, crops and vegetables, fruits, and other things that they will be doing. And after that, Brazil, and next China. So if you see China, and population wise, compared to us, it is going to be have much population, and area wise also compared to India, it's having a huge area, and they are utilizing so many technologies. So if I see some papers on precision agriculture, out of 10 papers, if you see, around 3 to 4 papers are from China itself. And next is Mexico. And after that, Australia and New Zealand. Even Australia is also developing harvesting vehicles and other things. And New Zealand and UK. These are the major countries. And current scenario in India is only 20 to 30% of the technology will be used. For example, soil to crop variability mapping, that will be, we are doing that. And along with that, the soil nutrient things, and spraying the chemicals using agri drones. And now this is going to be an open area of research, especially in case of Indian scenario. And next part is challenges. It's always there. See, n number of technologies are there in the market, but in order to adopt those technologies, so is that possible for us? In a single shot, we can buy everything. So that is not at all possible. So in case of challenges, so I have listed few challenges, that is with respect to India. So in implementation, one thing is nothing, infrastructure. There is no proper infrastructure. That is nothing but a digital platform. So even Digital India started growing. Still few more time yet to come. So in order to reach everything, and also 5G technology, that is also going to hit the market shortly. Few things already there, but not proper 5G technology. And whenever everything is set, the digital platform and everything will be set, then we can adopt precision agriculture and also a number of computing technologies into agriculture. And another thing is excess of initial cost. This is always there. So for the first time, I want to introduce something in the sense. So obviously, cost will be more. So how to do that? So once again, it is, government has to decide, come up with certain subsidies and other things. So already they are doing so many other, farmer friendly things that they are doing. They are coming up with different schemes also. But it will take some time in India, another 5 to 10 years. So even we are able to do that, we can afford. And affordability by medium and small farmers. So in Western countries, if you see that, the area of the farm is going to be huge. At least minimum, it will be 10 to 12 acres, 10 to 20 acres and other things. But in India, if you see that, that is not the thing. Because farmers are divided into, medium and small scale farmers. So medium in the sense they will be having 5 to 6 acres land. Small farmers are having only 1 to 2 acres of land. So if they want to adopt these technology into their field, so it is going to become, it is not that much cost effective. And these are the challenges, this needs to be addressed. So before we are going to adopt the new technologies as well as precision agriculture, so into practice. And these are the few papers that I have referred. So in my research also, and for this presentation also, I have referred these papers. So with this, the presentation is completed. If anybody is having any questions, I love to answer. Any questions from audience?